Hi, for our cool topic project presentation, we decided to cover the topic of security for cyber physical systems. Next slide, please. Cyber physical systems are smart network systems with sensors, processors, and actuators that interact with the physical world and support real-time performance and safety-critical applications. This includes automobiles, medical devices, and building controls. Next slide, please. Security for cyber-physical systems refers to the security concerns for cyber-physical systems and Internet of Things devices, which both play a significant role in infrastructure, government, and our everyday lives. The Internet of Things describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. Internet of Things devices include the forward collision prevention capability of a car and a medical device's ability to adapt to circumstances in real time. These systems are a source of competitive advantage, however, they increase cybersecurity risk. This results in the necessity to strengthen security and reliance for these systems. In this presentation, we will be diving into the cyber-physical systems architecture, which has three main layers of perception, transmission, and application. Next slide.
So the perception layer of cyber-physical systems mainly involves all the sensors and other types of devices that are actually gathering data. They can be spread over large geographical areas, interact with many different places. Some examples of the devices that are used would be GPS or radio frequency identification tags. Next slide, please. Some of the security risks that come with the perception layer are physical attacks on these sensing devices, eavesdropping on the data that the sensing devices gather and send out, as well as hardware Trojan horses that affect the hardware of the sensors. Some ways to manage it are calibration, which is essentially cleaning up the data that the sensors transmit, end-to-end encryption, which makes sure that between the layers all the data works well, as well as a hardware anchor-based IANA solution, which works to essentially monitor the entire system. Next slide, please. Transmission layer is also known as the network layer. It processes data between the perception layer and the application layer, and is important that this layer is secure as it helps prevent malware, distributed denials of service, or eavesdropping. Some examples of this include Wi-Fi routers, LAN, 4G and 5G, and the cloud. Next slide, please.
The transmission layer also has various security risks and security management tactics. At the transmission layer, some security risks that we have are malware and data theft, DDoS attacks, and eavesdropping or session hijacking. And some ways to mitigate those risks are strong password management, strong authentication, lightweight dynamic symmetric encryption, and secure tunneling. Next slide, please. And then that brings us to the application layer. And the application layer processes data from the transmission layer and issues commands. The application layer also requires complex decision-making algorithms so that it can make correct decisions based on the information given from the perception layer, and it also directly interacts with the physical world. Some examples of devices at the application layer are smart traffic control, smart street lighting, and smart energy management. Next slide, please. And the application layer also has some security issues. Some security risks include unauthorized access, privilege escalation, and data leaks. And some ways to mitigate those security risks would be to implement multi-factor authentication, data masking, and data anonymization. And those are just ways to encrypt data so that if it does leak, it won't be too bad. Next slide, please.
In conclusion, cyber-physical systems are smart network systems that interact with the physical world. It has numerous applications in agriculture, energy management, environmental monitoring, and intelligent transportation, medical devices and systems, process control. A cyber-physical system architecture has three main layers, which are perception, transmission, and application. Um, these are some of the citations that these are some of the sources that we used in our presentation. And thank you so much for attending this.